Assalamu alaikum warahmatullahi wabarakatuh. Hi everyone. Today we are going to continue our discussion about vectors, and we will start with a principal concept called a unit vector. What is the meaning of unit vector? Unit vector in a normed vector space is a vector of length 1. For example, any vector that we have, it has its own unit vectors. For example, if we have a vector A, which has ordered pair 3 and 4. It is position vector from 0 and 0. Start point and ending point is 3 and 4. We can make a unit vector for this vector with two conditions. The first one, the angle of the unit vector must be the same angle of this vector. In another word, it lies on it. It lies on it. The second condition, the magnitude or the norm of this unit vector must equals 1 unit. For example, this one. This is a unit vector. If its length equals 1, then we can say that it is a unit vector because, of course, it has the same angle of the vector A. The unit vector is denoted by the symbol hat. A hat means a unit vector of vector A. So A hat equals, this is the formula, vector A over the norm of vector A. So to know its rectangular form x and y, just substitute. The vector A equals 3 and 4. Of course, the norm of vector A equals 5. So we will just substitute in this formula. A hat equals vector A over norm vector A. So it will equal 3 and 4 in order pair divided by 5. So the x and y for this unit vector for x equals 0.6 and for y equals 0.8. To make sure of our solution, calculate the norm. You will find that it is equal 1 and the angle must be the same. For example, tan theta 0.8 over 0.6, it is the same as 4 over 3. So we calculated and we found a unit vector for this vector. Okay, let's move to another part. Expressing the vector in terms of the fundamental unit vectors. If we took a part of the positive direction of x-axis equals 1 and we named this point with the symbol I, which has its own ordered pair 1 and 0, then we have a fundamental unit vector called vector I. Vector I, it is the directed line segment with a starting point to the origin point, and its norm is the unity, which is 1, and its direction is the positive direction of x-axis. This is another way from scientists to represent vector. Instead to say vector A equals 3 and 4, for example, so we can just say 3i vector. Do you understand? It means that instead of saying the part taken of the positive direction with x-axis, we just say vector I. And the part taken from the negative direction of x-axis, just say negative I. Do you understand? The same as for j. The part taken from y-axis, the fundamental unit vector j, it is a directed line segment with a starting point to the origin point, and its norm is the unity, and its direction is the positive direction of y-axis. It is another form, another way to represent vector. And this called engineering notation. We have three forms, as we will study right now. We have three forms. Rectangular form or Cartesian form, it is the same. Polar form, which is norm and theta. And the first one, it is the same as this one, which is fundamental unit vectors, engineering notation. And it is the same as a rectangular form, but instead of putting it inside ordered pair, just say vector I and vector j. For example, to understand this one, express each of the following vectors in the terms of fundamental unit vectors, or another way to say it in engineering notation. N vector or vector n equals 4 and negative 3. This means that the part taken from the positive direction of x-axis equal 4 and the part taken from negative direction of y-axis equal negative 3. We can just say it 4i vector minus 3j vector. Do you understand? It is the same. It is the same way to represent, but with another shape, another way. Okay, everyone, this is the same, and this is the same. You can try by yourself. So as we said that we have three forms: the rectangular coordinates x and y, polar coordinates r and theta, engineering notation x in the direction of vector I plus y in the direction of vector j. It is the same as the first one, but don't put it inside ordered pair, and denoted by I and j. And if it's 3D, it will be I, j, k. And we said this note before, how to convert from rectangular coordinates and polar coordinates. Please revise the previous session. Adding vectors. This is the second part of our session today, and the last part. We said before, if we have a vector A right here from 0 to A, and we need to go from A to another point B, so the displacement of the total journey will be this part, which is OP. Do you understand? We have done addition vector for vectors. We said that vector A plus vector AB, this is what we do it right now, and the result will be the displacement. It is the distance or the line segment from the starting point to the ending point, and of course you can see that it is a position vector B. So we can say that vector A plus vector AB equals vector B, and we concluded this formula before. Please revise the previous session. We concluded before, nothing new until this moment. I will use this concept to know how to add vectors, but please don't forget that the start point of the second vector, it is connected to the end point of the first vector. Don't forget how to make addition. Do you understand? We must have a displacement, okay? So we have a problem here. Vector A equals 1 and 2, vector B equals negative 2 and 3, and we need to find vector A plus vector B. Of course, we can represent in orthogonal coordinates x and y. Vector A, which is 1 and 2, vector B equals negative 2 and 3. And we have a little problem that they are not connected as we expected. Do you understand? The second vector, or even the first vector, we said the initial point or the start point of one of them must lie or connect to the final point of the other one. Again, we must to add two vectors that the end point of one of them must lie on the starting point of one of them must lie or connect to the end point of the other. So we have two ways to solve this problem. Either that I can take this vector and put it here to make it right, or to put this vector on this one. Do you understand? And of course they are the same because we will have a rectangle. They are the same. We will have the end point. So we will use the equivalent vector. If you remember in the previous session that we talked about the equivalent vector. It is the same vector, but give me or satisfy two conditions. The first one, it must have the same angle parallel to this vector. The second one, it must have the same magnitude. If you made another vector the same magnitude and the same direction, so this is the same vector that you are dealing with. And of course we can just make a copy of this vector and put it here. This is equivalent vector. It is the same as this one, but in the right place. Huh? The ending point of the second vector, it is connected. The ending point of the ending point of the first vector, it is connecting to the starting point of the second vector. Again, the ending point of the first vector is connected to the starting point of the second vector. Of course, you neglect about this one as if it is not here, so the displacement is the answer. And you can calculate what is the point here. You can see the order point here, it is -1 and 5. So the result will be -1 and 5. And if you focused on the answer, you will see that it is as if we algebraically added the x and y. 1 plus -2 equals -1. 2 plus 3 equals 5. And this is how we prove it graphically or geometrically. You understand? So instead of just making a copy and put the endpoint to connect the first point of two vectors, just add the x and y together, x together and y together, and the result will be the adding vector that you need to find. I hope that you understood this session today, and we will get back again with last video of vectors. See you soon. Goodbye.